Theory. There's 3 parts. Now here's the deal. I'm not going to show you all 3 parts. So if 2 are true, if you have 2 parts, then you can mark the 3rd part as true. So what we're kind of saying is if you have A and B, then you know C exists. Or if you have C and B, then you know A exists. Or if you have A and C, then you know that B exists. So any 2 parts, then the 3rd part you need to mark on your diagram. That's what I mean by mark. I mean write it on your diagram. So one part is a line from center. So you might not be able to see it on your diagram, but there must be a dot showing that a radius or a diameter comes from center. Radius or diameter. The other part is that the chord is bisected. What does bisected mean? Separated? No. Cut in half. Okay. So how do we mark that this line AB? So AB is your chord. How do we mark AB being cut into 2 equal pieces? You can put a simple little line through it. You can put 1, or you can even put 2 if you want. But they have the same markings. So right now you know that AE equals EB. Okay? And that's important. So if you have the whole chord, you can divide it by 2 to find one of the little pieces. Then the 3rd part is that the chord is perpendicular to the line from center. What does that really mean, though? It means that they meet at 90 degrees, or they cross at 90 degrees. So you should put a blue 90-degree symbol on there. Now you don't have to mark all of them as 90, you just need to mark one. But in fact, yes, the whole thing, it's 90, 90, 90, 90. But you just need to mark one of them as 90. So that's the 3 parts. Okay? A line from center, 90 degrees. Now, what this allows us to do is we can then draw the hypotenuse, and this is actually the radius as well. And that's really special because I say the dimensions of the radius and I actually give you numbers of 2 lines by only saying one thing. Okay, tricky, tricky. So what we can do then is do some calculations. We can find the length of CE or AE or AB or even ED. Okay, or you can even find, right, if I say or even CD, the radius. Okay, this green line you're not going to be given all the time. So if you're stuck, you need to draw that line. Okay, so let's do some practice questions. Example number 1. You want to find the dimensions of AB. So we have a line from center. We have it's at 90 degrees. So what do we have to mark on our diagram? that these two are equal. And if you don't do that, I take marks off. Okay. So now, how can we find x? Yeah, you could do Pythagoras. So x squared equals the hypotenuse minus the leg. Of course, they're squared. Go ahead and find x. So you should have a calculator out. You're going to be doing a lot of squaring, square rooting, okay? Okay. So show your work, please, because that's what I'm marking. So 144. So then x equals square root 144. That's your grade 10 answer. Grade 9, we'll go to our decimal. X equals 12. So what does AB equal? Yeah, 2x. So it equals 2 times 12, which equals 24. Okay. Now you got to be careful, because sometimes we'll just ask for x, other times we'll ask for the whole line. So don't assume anything. Read carefully. Don't just be a robot. You need to read. Okay, let's try the next example. Write this information on your diagram and mark the third piece, okay? The third piece of the chord theory. Go. So you should have DE as being 2. You should have drawn the 90 degrees. You have a line from center, the chord being bisected. You must draw this 90 degrees. That's extremely important. Okay. Then you also know EF is 8. So if this whole thing is 8, right, then what is CB?
10. 5.
How'd you get that?
Because you add the 8 and the 2 together.
That's right. You can't use the 8, but the whole thing, FD equals 10, so then CB must equal 5. So if CB equals 5, what does CE equal? 3. Okay. So this 3 is from 8 minus 5. Sorry. 5 minus 2. Thank you. Okay, 5 minus 2. So we just have to do a whole bunch of little numbers there. Very careful. Okay, so now I want you to find what is EB squared. If you want, you could call it X or a Y, but I'm just going to use EB. So find EB, because that will help us find AB. Now, if you're doing a lot of work, it's nice to put your final answer in this box so it's easy to see. So the entire line AB, that equals 8. Any questions? So you're doing a little bit of calculation. Next one. Find AB. Okay, so mark your chord theory, please. What's the first part of the what do you have to mark? You have a line from center. You have 90 degrees. So you got to mark those two lines as being equal. Okay. And this is 12. So this one you got to do Pythagoras twice. You got to find x. Okay. Once you find x, then you can find y, then you can do Pythagoras to find w. This is a challenging question. This is one of the hardest ones. Okay? So do Pythagoras to find x. So if x equals 9, what does y have to be? Well, it would be CB minus x. You do a subtraction. You would take this chord, so this radius AB, and you would subtract. Okay. So y equals 15 minus 9, y equals 6. Okay. So that's something that's tricky that we haven't done yet. Okay, this part here. So you'll have to do a subtraction to find numbers. Now you can do Pythagoras one more time to find w. Go ahead, do Pythagoras to find w. So 13.4. Ends up you got 13.4. All right. Any questions? This next one, you eventually want to find the area of the triangle. Remember, area of a triangle is base times height divided by 2. Okay. Well, there's no 90 degrees anywhere, so we can't find the base and the height. Because base and height join at 90. So I guess we can't do the question? Yeah, what?
The lines have that little hash thing,
So there's a line from center. We have the hash marks. What's the third part of the chord theory?
it gets bisected.
90 degrees. It gets bisected. Okay. So now we have a base and the height. Mark these numbers on your diagram. Try and find the base and the height. Go. In order to find AB, you need to add this line here. And how long is that line called the radius? 5. So now you can use 5 and 3 to find AB. Okay, so go ahead, find AB, and then you'll be able to find the area. Because this top part's the radius, and it's 5. Okay? So they're playing around with you. Are you sure? Do your work, please. Show it. Don't just say it. I was just at UFE math contest, and every year he says the same thing. You can get every question right in the math course and fail it, and you can get every question wrong and still pass it, because it's all marked on what you show. Right? You need to be able to explain to someone you know what you're doing. So that's why showing work is really important. Okay. Okay, once you find AB, then you can find the area. Oh, inside or out? So that's going to be 8 times 4, or 4 times 8, divided by 2. So the area is 32 units squared. Make sure you have units squared. Oh, 16, thank you. There we go. Okay, next page. Now we have some applications. Please draw the diagram and label it. Do the best you can, okay? Okay, so 100 centimeter diameter. It's inspected by a flotation device. The surface is 80 centimeters across. Now what's interesting to know is if it's 100 centimeters diameter, that means this line here is 50 centimeters. It's half of 100. So you need to draw that line and label that as 50. Okay. You know that the line that I drew straight up from center cuts this in half. And then it also meets at 90 degrees. So you must draw all the parts of the chord theory. Okay. The line is bisected, perpendicular lines, a line from center. Now the whole thing's 80 centimeters across. This one's only 40. So what we want to do is we want to figure out X, then we can figure out Y. Okay? Because that's what they're asking. The clearance is Y. What's the distance between the water and the top? Okay? So this here is your clearance. How much empty space is there in that pipe? You did a question just like this. Do Pythagoras to find X and a subtraction to find Y. Go. In this short little sentence, 20 centimeters of clearance. Is it just me or the air conditioner just kick in? Okay, hands up, you got 20 centimeters. Really similar to the other questions you've done, isn't it? We can't make up too many questions here, folks. So don't get too crazy on us. We're keeping them pretty simple. Now we have a different type of question. So now we're going to look at the angles. So some of these questions we'll talk about are going to involve Pythagoras. Others will involve the angles. So HJ is the diameter. What is angle 1 then? Here's 130. What's angle 1 got to be? This feet are in the same spot. Angle 1 is 65 degrees. Why? Angle 1 is inscribed. What's 130? Central. Okay, so this is going to be inscribed equals the central divided by 2. So that's the reason. Please write the reason because that's more important than 65 degrees. Okay. What's angle 2 got to be? 90 degrees. Why? It's the third part of the chord theory. Right? We have a line from center and the chord's bisected. So we got to add the 90 degrees. Okay. Angle 3, how are you going to find that? Okay, you should finish the rest yourself. Go for it. I'll give you a minute. Try and get them all now. Okay. It's not important that you have the answer. It's important that you have all the thinking on the outside. So these are all the reasons on why you have that value. So this one is going to be the triangle. Okay, triangles add to 180, so you subtract. Number 4, here's number 4, and here's angle number 3. They have their feet on the same arc, JM. So that means they have to be the same. So that's why you have it's inscribed to the same arc as number 3. They should be the same. Angle 5, you have a straight line right here, which is 180 degrees. So those other two angles add up to 180, so we can subtract. Okay. So 130 minus 180 equals angle 5, the leftover part. Angle 6 is going to be another triangle, so the triangles add up to 180, so we can subtract 180 minus 5 minus 90. Remember, it's 90 degrees on both sides of the line. And then for angle, angle HMJ, here's your diameter, and here is the inscribed angle. So it's inscribed to the diameter. That's one of your rules. Remember, it's the central divided by 2, 180 divided by 2. So those rules go hand in hand together. This is what you should be thinking for every single question you did so far this course. Why? Okay. Otherwise, you need to ask because you're not learning. Any other questions? Okay, next one, number 7. How could you use the chord property to locate the center of the circle? So what are the 3 parts? 1, line from center. 2, chord is bisected. And number 3, they're perpendicular. Well, if you want number 1 to be true, you want a line from center, you must then draw these two. Because if you draw those two, then you know that your line goes through center. So take your ruler, draw a chord. If you don't have a ruler, use something straight like an eraser, calculator, sheet of paper. Every fold you make in a piece of paper will be straight. Okay. So then what you want to do is measure it so you know where halfway is. Okay. And then draw a line that's perpendicular. Okay. So as soon as I draw that, I know that that's the diameter and center is somewhere on that line. It's still not enough to locate center. Any ideas on what I could do to locate where exactly is center? Easier. What if you knew, yep.
Like the middle of the...
The chord theory twice. Because if you draw it twice, both the green and the red must go through center. So now you know where the center is. Any questions? Okay. Perfect.